In this video lesson, we will talk about assembly files in Inventor, as well as how to assemble your Automata project. What is an assembly file? An assembly file uses multiple IPT parts and makes one functional system in Inventor. The benefit of this is to see how the design will actually function and work, and can be used for many other things like marketing and business. To begin an assembly file in Inventor, on the home page, click the assembly icon. You will notice this looks a little different than the part file setup. In the top left here, we have the assembly ribbon, an assembly tab. We also have other tabs that we will get to in later lessons. The first part that we place in the assembly file is very important. This is called our base part. So every part will be constrained to the center component. In this project, we will place the box as our first base component. So under the assembly tab, go to place. Find your part. In this case, it is my box, and open. You can zoom out. You may wish to change views here in just a minute. Click to set, right click, and OK. To change the views and make the correct front view, simply move your cube around and set your front view if needed. Also set your home view if needed. Next, we need to ground this component. What grounding means is it's going to remove all degrees of freedom. All objects have 6 degrees of freedom. A degree of freedom can be defined as movements in the X, Y, and Z direction. Because you can move both ways on each axis, you have 6 degrees of freedom. To ground the box, right-click the box and find the feature called Grounded. Click the check mark. Two things happen. One, you can click and hold to try and drag your box and it will not move. The second thing that happens is the icon with a pin shows up. Once you have successfully grounded your box, we are going to place the next part. I would recommend placing the axle handle. This makes sense because the axle handle holds your cams together. Before you constrain the axle handle to the box, we must first rotate the axle handle. Rotating parts in the general direction is always a good practice, and we can use the free rotate option here. Using the free rotate option, you should see a circle that pops up. If you hover inside the circle, you have what's called free rotate. This can be a little bit different to handle as all of the axes are being controlled at the same time. If you notice that there are axes on the sides and the top and the right sides, as well as the circle, these are called axis rotation points, and you can use these to freely rotate your axle handle. And I just want it going in the general direction. Press escape to get out of the tool. Next, we are going to talk about constraints. A constraint is how we constrain individual degrees of freedom or different axes. To apply a constraint to a component, go to where it says under the Relationships tab, Constraint. Click Constraint, and we will talk about the different types of constraints throughout this lesson. We will also talk about how to select and using selection arrows. We will also talk about the different solutions in each of these types and how they apply. What we are going to first do is we're going to apply our first mate. A mate is the option or type 1 and option or solution 1. Solution 1 is called mate, and this is when two surfaces come together. we are actually going to mate the axis of this axle handle. You know you've selected the axis of this axle handle when you hover over the rod and dashed white lines appear. Click the axle rod when these white lines appear. Next, since we want to place the axle rod into the hole of the box, we want the axes of this hole to match. So we will use the inside hole and hover again for the inside surface for the white dashed lines and click the surface. It's okay if the object or the component does not look exactly where you want it to go. This will come as you move through constraints. Click Apply between each constraint. Next, we are going to create an offset mate constraint. What this is going to do is, if you notice that our axle handle, it moves along the axis just fine. However, it moves inside the box, which we don't want it to do that. We want it to move and stay in place while we rotate the axle handle. If you notice, while we're moving the axle handle and the box into the box, two surfaces meet. This is a good indication that we will use a mate constraint. We will use a mate constraint on the back side of this handle to the right side of the box. To apply the constraints, we will use the constraint tool once again, type 1 mate and solution 1 mate, where we will select the right side of the box to the back side of the handle. Notice that our handle goes inside the box further than what we want it to go. We can offset using the offset dialog box. This offset dialog box will allow us to offset the handle for various locations. I want my offset to be 0.75 inches, or maybe 1 inch, whichever one is going to work best for your design. Click Apply. To monitor and see if the axle handle is moving correctly, click Cancel to get out of the constraints box and move your axle handle. Notice that it moves and stays in one place. The next step in the Automata Assembly process is to assemble the cam to the axle rod. To do this, place your cam inside your assembly by selecting the correct cam, placing it in the assembly, and moving it and orientating it however you need to help get it in the general direction. Just like the axle rod and axle handle, we are going to assemble this by using the openings, a circle opening of the cam and the rod itself of the axle handle. This will be the same constraints. We will use a type mate and a solution mate. So again, select the inside surface of the opening of the cam and the axle rod and click Apply. As you work through the assembly process, don't be afraid to move parts around and see how they function. As you can see, the axle handle is not moving the cam like we are wanting to do so. So we have a few more constraints. Likewise, if we move the cam, you notice that it spins freely on the axle rod, but it's still pretty loose. So the next step is to constrain two work planes, one work plane from the cam and one work plane from the axle handle. At this point, the box is not helping us at all, so we will right-click and suppress the box. This temporarily hides the box. Also, if you look in the browser, it also is still there. It is just crossed out with the words suppress. To unsuppress, right-click and uncheck suppress. Now that we have an opening, we can constrain two work planes of our axle handle. While we spin the axle handle, it is worth noting that two planes overlap each other. Those two planes identified are this work plane of the cam and this work plane of the axle handle. To constrain, go up to the constraint option. We will use again type mate and solution mate because two surfaces are coming together. Select the work plane of the cam and the axle handle. Notice how the cam and the axle handle move in place together. Click Apply. Notice that the cam and the axle handle move together. Also note that the cam still moves side to side. We will take care of this once we get the follower inside the box. It is recommended that you repeat this process of importing cams into your assembly file. This next cam I'm going to show you is I'm going to do a little bit different of a constraint, which is an angle constraint. And I'm going to use my pair cam to demonstrate with this. Bring in your pair cam. Of course, you're going to first always assemble the axis of the cam to the axis of the axle handle. Next, we are going to apply a what's called an angle constraint. An angle constraint is different than a mate. This is a type 2 angle constraint. Notice that we have up to three selections that we can choose from and 3 different variations of solutions. You also notice the angle dialog. We will get to this once we have selected our surfaces. We want type 2 angle with solution 1. That gives us 2 surfaces or 2 objects we can angle constrain. Just as before, you are going to still select the same work plane of the axle handle to the work plane of the axis of the cam. And just as before, the cam is aligned with the axle rod. Next, we are going to use the angle dialog box, and we're going to type in an angle. The reason why we use an angle constraint for this type of design is for timing purposes. For example, let's say we do instead of it being 90 degrees, we make it 45 degrees and click Apply. Once you have all of your cams on your axle rod, unsuppress your box from the browser. Once we have this box back and unsuppressed, we will place our followers in this box. I want to take a moment and explain the browser and how the browser works in an assembly file. Your parts now have constraints, and we can expand all of your parts by clicking the arrow just as you would in a part file. The difference between a part file and an assembly is that you have constraints. And in these constraints, you can modify each offset or every setting of that constraint. Be careful though, and be mindful of when you modify a constraint, it may affect other constraints. For example, mate 1 is first. If we modify mate 1, it may affect mate 2 through 5 or even our angle constraint. These are listed in order by which they were applied. You can right-click and delete constraints that are conflicting by simply right-clicking like you would any feature or sketch in a part and then deleting it. And if you need to edit, you may do so by right-clicking and also going to Edit. By doing this, you can bring up the dialog box and reconstrain or reconfigure your constraints. For example, an offset. If you need to change the offset, you can do so there or change your solutions, but just keep in mind that those changes may affect your other constraints. I'm going to show you what an error looks like and how it may look in your constraint. Let's take, for example, one of our cams. I'm going to pull a cam out and I'm going to constrain something very odd, like maybe the axis of the cam to maybe the axis of another option and click Apply. Now, before I even clicked Apply, notice that nothing happened. That is your first red flag typically. This isn't always the case, but it could be a troubleshooting tactic. When I click Apply, I notice that I get this sound and it says, assembly cannot be solved. and it's saying the relationship. It's talking about the relationship. No, Inventor is not giving you relationship advice, but it is talking about two components not getting along with each other. So you can choose to edit the relationship, cancel the operation, accept the relationship, or diagnose. You can try all of these options. If you go on and edit the relationship, it is going to take you back to the dialog box. If you cancel the operation, it will take you back to the place constraint dialog box. If you choose to accept the relationship, it may allow you to accept it for a short period of time, but it may throw a flag at you or a warning signal. And diagnosing a relationship may help you find out what went wrong. So I'm going to go ahead and accept the relationship, even though I know it's a totally bogus one. But for the sake of demonstrating to you, I want to show you one thing about this relationship. Notice that I try to click the component and it's stuck. And notice too that my whole cam fixture is stuck. I no longer can move my axle handle. Also, take note of that constraint. I now have a yellow sign with an exclamation mark next to that constraint with the box. That same constraint happens down here with my snail cam. It's the same constraint because this is a mate 6 and a mate 6. They both have the same constraint. So as you apply these constraints, take note on that these components now share the constraint. If you see an error like this, you must delete it or edit the relationship. I'm going to right-click and delete this relationship. And after I do that, I can now move my cam in place where I need it to go and spin it freely. While our cam is out, I'm going to demonstrate how to place the follower inside the box. This is fairly easy and compared to the cam and the axle handle. Go to Place, find the follower which you are wanting to use, click Open. Notice that I have 3 or 4 holes. If you have the same setup on your box, you may choose to place 3 or 4 followers. I may not place all of these in the demonstration, but just to show you that you can place multiple parts simultaneously, you can have them. Just as before with the axle handle, let's go ahead and free rotate this follower in the right direction. I also need to point out a couple things with the follower. The follower is important because this is going to actually move with the cam. I'm going to rotate it so that this is going completely in the right direction. We also need the work planes accessible, so we will follow through. So here's one thing that I did not demonstrate to you. If you click the component you want, you will see it highlighted in the browser. There's a connection. I'm going to make one of these visible, or one of these work planes visible, so that way I can align it later on for this lesson. To make this visible, I'm going to highlight a work plane that goes through the middle, and in this case, if you're using the follower that I've provided, it's called Mate with Midplane of Cam. We are going to right-click and check mark the visibility on this work plane. Next, I'm going to mate the axis of the follower to the axis of the hole opening in the box. What you should be able to see with the follower is that it freely moves up and down. Notice that I mated it and I did not use any other constraint option. This is the only mate constraint option at this point. Next, my cam. Notice that I can still move it. Next, I'm going to actually constrain this work plane that's going midway through the cam to the midway cam of the follower. Just as before, you select the midplane and the midplane of each component and click Apply. Once you have applied, click Cancel, and you will see that your cam was still moving, but the follower is not. There is one more constraint that will conclude how to assemble your cams to your box. The last constraint we must apply is the transitional constraint to the follower and the cam. We're going to use the constraint option again and also use the tab called transitional. I'm going to apply one surface of the bottom surface of the follower to the top surface of the cam. Notice that the follower should move to the cam. Click Apply. The next demonstration I'm going to show you is what happens if this relationship doesn't in fact work with the transitional. I'm going to delete my transitional constraint and actually start over with how I can help with those who are experiencing some technical difficulty with this process. Let's just say the relationship didn't go through like you had hoped. One troubleshooting tactic that has been very, very successful is using a tangent constraint, which is an option 3. Use the tangent constraint with the outside option and apply this tangent constraint just as I showed you with the transitional. Apply it to the bottom of the follower, to the top of your cam. Click Apply. This typically works as far as placing your cam. Sometimes it may even work with moving. However, you get to a point and it stops. So we're going to cancel this operation. Notice that we have the tangent down here. That was intentional. We must now delete your tangent constraint. The whole purpose of doing this was to trick Inventor. So now we're going to constrain, use transitional, just as before, and we are going to select the bottom of the follower to the top of the cam once again. This should work. Click Apply and move your cam. Continue to apply the followers and cams as necessary. This concludes the assembly of the cams and the axle handle portion of your project.